Hey everyone, today we're going to crack one of the most important ideas in differential equations, general and particular solutions. I know this topic can sound a little confusing at first, but trust me, by the end of this, we're going to make it absolutely crystal clear. So let's get started.
Think about it, right? When you solve a simple algebra equation like x squared minus 4 equals 0, what do you get? A number, like x equals 2 or x equals minus 2. Simple. But have you ever stopped to wonder what the solution to a differential equation actually is? What does the final answer even look like?
Well, here's the big reveal, and this is the most important idea for today. The solution is not a number, it's a function. And not just one function, but very often it's a whole family of functions that all share a common rule.
So, to make this super clear, let's start with the first main concept, the general solution. And honestly, the best way to understand this is to think of it like a viral trend on social media.
You've all seen them, right? That one dance challenge or that Instagram reel audio that suddenly everyone on your feed is using. You know what I'm talking about.
Now think about it. Every single video in that trend follows a basic template, doesn't it? They all use the exact same audio, and they all have the same core dance steps or choreography. Those parts are totally fixed.
But, and this is the key part, there are also customizable bits. Who is dancing? Where are they? What are they wearing? These variables that can change from one video to the next, well, those are exactly like the arbitrary constants in a differential equation.
And that, right there, brings us to the formal definition. A general solution is a solution that contains these arbitrary constants, like C, A, or B. And because these constants can be any value, the general solution represents an entire family of functions, just like that viral trend template represents a whole family of thousands of unique videos.
Okay, so if the general solution is the viral trend template, then what's next? Well, that would be the particular solution, which is like your own unique video that you decide to post.
Just think about it. When you decide to make your own video, you lock in all the variables. It's not just someone dancing anymore, it's you. It's not somewhere, it's in your room. It's not sometime, it's today, on a specific day. All those customizable parts are now fixed.
So basically, you've replaced all those arbitrary, customizable parts with particular, specific values. There are no more variables left to change. Your video is now one single, real example of that big trend.
This connects perfectly to the official definition of a particular solution. It's a solution that is completely free from any arbitrary constants. And you get it by taking that general solution template and plugging in specific values, which usually come from some initial conditions given in the problem.
All right, let's put it all together in one simple table so you can see it side by side. The general solution is the viral trend template. It has those arbitrary constants like C, and it represents a whole family of curves. On the other hand, the particular solution is your specific video. It has no arbitrary constants, and it represents one single specific curve from that family. Now, I'm going to share a simple but super powerful rule that connects all of this. I like to call it the order constant connection. And seriously, if you remember this one thing, you'll avoid so many common mistakes. Here it is. A general solution of a differential equation with order n will have exactly n independent arbitrary constants. It's a direct one-to-one match. Just remember this golden rule.
Let's see it in action. Suppose you're given a differential equation and you see that its order is 2. For example, it has a d squared y by dx squared term in it.
Then you immediately know that its general solution must have exactly two arbitrary constants, like a and b. If the order was 3, you'd look for 3 constants. If the order was 1, you'd find just 1 constant. See? It's that simple.
Okay, enough theory. How do we actually prove that a given function is a solution? This is a really common question in exams, so let's walk through the process. And trust me, it's very, very straightforward.
Here are the 4 simple steps. First, you differentiate the function they give you, as many times as the order of the differential equation. Second, you substitute everything, the original function and all its derivatives, into the left-hand side of the equation. Third, just use your algebra skills to simplify that left-hand side. And finally, fourth, you compare your result with the right-hand side. If they match, congratulations, you've verified it.
Let's walk through an NCRT example, step by step, no steps skipped. We have to verify that y equals a cos x plus b sin x is a solution for y double dash plus y equals 0. Okay, step 1, we find y dash and then y double dash. Now for step 2, we substitute y double dash and the original y into the left-hand side. This gives us minus a cos x minus b sin x plus a cos x plus b sin x. Now step 3, simplify. And you can see that everything cancels out perfectly. We're left with just 0. Finally, step 4, compare. The left-hand side is 0, and the right-hand side is also 0. They match, so it's verified.
Pretty simple, right? And let's connect it back to our golden rule. The order of the differential equation was 2, and our solution that we just verified has exactly 2 arbitrary constants, a and b. This confirms that what we're looking at here is a general solution.
That was fantastic work. Before we finish, let's just do a quick recap to make sure these key ideas really stick in your mind.
So just remember, the general solution is the template with arbitrary constants. The particular solution is your specific version with no constants. The golden rule is that the order of the DE equals the number of arbitrary constants. And to verify any solution, just differentiate, substitute, simplify, and compare.
And seriously, you're doing great. This is a foundational concept for the entire chapter. Once you really understand this difference between general and particular, everything else becomes so much easier. You've totally got this.
So always remember, a solution to a differential equation is not just some final answer. It's a function, it's a curve, it's a whole story about how something changes. Now go out there and solve the next one.